true. It can be hard to tell, but you mentioned, what you mentioned was, Chihuahuas and Great Danes. We all know they derive from a common ancestor dog. We have very, very well documented the history and the chronology of dog breeding. And yes, Chihuahuas and Great Danes are both dogs. You look at them, they all have 4 legs, they all have teeth, they all have fur, they all eat meat. So Chihuahuas and Great Danes and all of the other dog breeds out there are commonly accepted examples of microevolution. And even though they look very different, even though they look, they could look like different species, and in fact, some species of dog, by a biological definition, if they can't mate without human help, scientifically they should be considered different species. Now, Chihuahuas and Great Danes, they all have a lot of stuff in common. What do they have in common with wolves, a different species? They all have 4 legs, they all have fur, they all have canines, they're all members of the canid family. Now, what do Chihuahuas, Great Danes, and wolves have in common with cats? Still carnivores, still 4 legs, different bone structure, but they still have stuff in common. Cats, wolves, Chihuahuas, Great Danes, squirrels all have in common the same basic body plan, 4 limbs and a tail and a head. They all use the same genes to build this body plan. They use the same genes to circulate blood in their bloodstream. All of these, when you compare them with dolphins, okay, you lose the limbs, but you still have so many traits in common. So if a whole bunch of different species, if a whole bunch of different breeds of dog can arise through microevolution, and how we know they're different breeds is, we know their common descent, and we see the traits that they have in common. If that's microevolution, then macroevolution is simply looking at these traits and looking at how you can expand that out, and looking at the commonalities and the differences in different branches. Dogs started from one branch and branched out through human intervention. All of the tips of the dog branch have traits in common, and all of the tips have traits in common with that root. Now that root has traits in common with other roots, with the root of cats, with the root of foxes, with the root of wolves, with the root of deer, with the root of moose, with the root of bison, and the root of all of those have traits in common with the root of plants. And animals and plants have a root in common with eukaryotes, with sea creatures, which you can trace commonalities in life all the way back to the first. Now, another example he mentioned was the Cambrian explosion. This is a point which I find very interesting. The Cambrian explosion, to just reiterate and give a little bit of a heads up for people who don't know, is the phenomenon that about 540 million years ago in the fossil record, what we see is the sudden emergence of a huge variety of shapes. Before 540 million years ago, dating back to 2.4 billion or 2.8, whatever, there's a bit of controversy over whether some fossils are life or not. But before the Cambrian explosion, what we see is single-celled life. We see fossils that are evidence of mats of bacteria. We see fossils that are evidence of colonial kind of colony stuff. And then at the Cambrian explosion, 540 million years ago, all of a sudden we see huge amounts of different species get fossilized. Now, the reason for this, and it's not a magic designer, it's not an intelligent designer hitting a switch and then turning it back off. The reason for this is something very simple. At some point prior to the beginning of the Cambrian explosion, through natural selection, life unlocked something very interesting, and that is the ability to build itself a shell out of calcium. Calcium fossilizes well, and shells fossilize well. Without shells, you don't get a lot of fossils. You get soft creatures, you get soft-bodied creatures, and we don't see them in the fossil record because they don't preserve. The reason why we suddenly see a huge variety in the Cambrian explosion is because shells were invented, and then shells gave such a huge advantage that shelled creatures proliferated like crazy, split off through mutation into various different forms, split off to take on different kinds of lifestyles, different niches in kinds of body plans. And it's certainly not at all a sudden explosion. The earliest Cambrian fossils we see are little worms, are little very simple fishes with a single spine, are very simple shapes. It's only later in the Cambrian explosion, way past the 540 million year mark where it started, that we start seeing a radiation from those basic shapes into others. In fact, there's a clear tree you can draw of Cambrian explosion fossils, early, mid, and late.